Okay. Now, when you're working problems, especially these, you've got to consider a few things. Okay? We're just going to work on the horizontal ones today, and we'll start the angled ones tomorrow. Okay? So we're going to be working 1 through 5. You've got to decide what you're given when you do these problems. So you will use this case right here, case 1, for these problems. Okay? I'm going to help you. I'm going to work through these the problems and write down what we have and what we don't have. Okay? So for number 1, we have a horizontal force of 400 newtons. It's required to pull a trunk. I like to draw just a square box, and that's what I'm using. Okay? We have a horizontal force of 400 newtons pulling the trunk, and the trunk is a 1760 newton trunk. So the weight of the trunk is 1760 newtons, and that 400 is the applied force. Okay? So the weight comes down here, and that's where it should be longer. 1760. What is always equal but opposite the weight? Anybody? Normal. The normal. So we also know that the normal is 1760. Only because it's being pushed or pulled horizontally, not at an angle. Okay? Now, and it's coming at a constant speed. What does it tell me? We have no what? No acceleration. So we have none of that because it's at a constant speed. Okay. That also tells me that I have no net force. Because to have a net force, you have to have an acceleration rate. Okay? So we want to know what's coefficient of friction. If there's no net force, it's not accelerating, then the friction force is equal to the applied force. Okay? Or the force is causing motion. Because it's not accelerating, it's got to be equal to that. Okay? So to find the coefficient of friction, if this is the applied and it's also equal to the friction, then we can say if this is the equation, the friction force over the normal, all I have to do is say 400 newtons over 1760 newtons. What did I tell you? The coefficient of friction would never be over what? 1. Mm-hmm. Is that better?
Yes.
I think you need glasses, Austin. So my coefficient of friction is 0.227. Now number 2 is similar. The only thing different with number 2 is that you have a mass of a book, so what can you find with the mass? The weight, okay? So you've got a mass and you have a coefficient of friction. Okay, so if you have a mass, you can find the weight. The weight's equal to what? Yes, but it's also equal to which one of these forces up here that we need for coefficient of friction? The normal, okay? So when you find the mass, you can find the normal. You're given the coefficient of friction, and it's at a constant speed, so the friction force would be equal to the applied force. So that would, when you find the friction force, you've got the applied force, which is what's needed to push it. Okay? Now, we've got number 3. I'm just going to go through number 3 with you. Number 3 says you have a force applied. So this is FA, okay? Horizontally to the mass of the box, okay? And the box has an acceleration of that, and we want to know the coefficient of friction, okay? So, we have a mass, so we can find the normal, right? Okay? So you can find the normal by saying the mass times what? How do you find weight? Mass times what? Gravity, specifically gravity. So I'm going to put that like there, okay? You can find you've got the applied force. How can you find the net force? The net force is what's actually causing it to accelerate. Yes, but we don't have the force of friction, okay? So let's look at this. How about if we take the acceleration here and we can say net force is equal to the acceleration times the mass of the object. We used gravity over here, but now we're using the actual acceleration rate of the object. Okay? So, we've got the applied force, we've got the net force, and we said using this we can find friction by saying applied minus net, right? So that's how you find your friction force. When you find your friction force and you have your normal force, then you can find your coefficient of friction by using this. Okay? Now what I want you to understand is the 3 meters per second squared acceleration is not what you use to find the weight. The weight has to have 9.8. Okay? It has to. Okay. Try to solve number 2 and 3 without any help.